Hello, students. This is Saxon Algebra 2, Lesson 60. In this video, we will learn about indirect variation or indirect proportion. What is indirect variation? Supposing a problem states, for an ideal gas, pressure varies inversely with volume. This means that higher pressure means lower volume, and higher volume means lower pressure. Indirect variation is like a seesaw. When the pressure is up, the volume is down. And when the pressure is down, the volume is up. Higher, lower, just like a seesaw. So, the pressure of a gas varies indirectly with its volume. How do we write this in algebra? We write it like this. Pressure equals K divided by volume. K is called the constant of proportionality. But in indirect variation, K appears in a fraction. K is in the numerator, and here volume appears in the denominator. How will we solve a problem? Well, we will follow 3 steps. First, we will set up the proportion. Second, we will find K, the constant of proportionality. And third, we will do the algebra. So let's work through an example. The pressure of a gas is in indirect proportion to its volume. When the pressure was 1 atmosphere, the volume was 4.5 cubic meters. What will the pressure be when the volume is 10 cubic meters? So the first step is to set up the proportion. So in this example, we have pressure equals K divided by volume. Pressure is in indirect proportion to volume. The next step is to find K, the constant of proportionality. When the pressure was 1 atmosphere, the volume was 4.5 meters cubed. So I have plugged the values that we were given into the proportion that we set up. And by doing the math, I find that K is equal to 4.5 atmosphere meters cubed. Notice that we get weird weird units in science sometimes, but those weird units can give you confidence that you are on the right track. Finally, do the algebra. What will the pressure be when the volume is 10 cubic meters? So we're looking for pressure here, and we know that K is 4.5 atmosphere meters cubed, and we're going to be dividing by a volume of 10 meters cubed. Now, look what happens with the weird units. The meters cubed part cancels out, leaving you with atmospheres. Now, atmospheres is a unit of pressure. And so that has shown us that we're on the right track because we're looking for pressure. And so now all that remains is to do the math. And the pressure in this case is going to be 0.5 atmospheres. So think about it. The volume got higher. The volume started out at 4.5 cubic meters, and it went up to 10 cubic meters. And the pressure got lower. The pressure started out at 1.0 atmospheres. We didn't write it like that, but it started out there. And it went down to 0.45 atmospheres. So our answer makes sense. Okay, let's do an example from the text. This is example 60.2 that's on page 258. And it says, the number of revolutions per minute varies inversely as the number of teeth in the gear. If 40 teeth result in 100 revolutions per minute, what would be the revolutions per minute if the gear had 30 teeth? And so we go by our steps. Number one, we set up the proportion. The revolutions per minute, which we can abbreviate as RPM, I'm sure you're all familiar with that, is equal to K divided by the number of teeth, because it says that the number of revolutions per minute varies inversely as the number of teeth in the gear. So there's our proportion. Next, we're going to find K, the constant of proportionality. If 40 teeth result in 100 RPM, oops, I wrote an RM, RPM. Okay, so that's what we can use. So solving for K, we get K equals 4,000 RPM teeth. Weird units again. So we've got our K, our constant of proportionality. What would be the RPM if the gear had 30 teeth? So we're looking for RPM. We have our constant of proportionality, teeth, and we're given the situation where there are 30 teeth. Once again, the weird unit is to our advantage, because when teeth canceled out, we're going to have RPMs equals RPMs, and that's exactly what we should have. And so when we do the math, we're going to find out that the final answer is 133 1/3 RPMs. That was a very familiar RPM in my day. So I hope this video helped you to master indirect variation. See you next time.